All right, so today we're going to talk about complex numbers and how to manipulate and work with imaginary numbers. So, kind of a review from before the last section, we want to think of what are the maximum number of zeros for this function. That comes from the degree. There's a maximum number of 3. If we look at this graph, how many real numbered zeros are there? Well, it only crosses the x-axis once, so there's only one real zero. But the other two have to exist. They have to be there and be something. So it have to be something that's not real or imaginary. So here's the number tree, just to kind of remind you of where numbers go. Complex numbers are over everything. You can break that down into real numbers and imaginary numbers. So your imaginary is something with an I in it. Complex numbers is anything of the form A plus BI. Real numbers are just like an A, like a 1, 2, 3 decimals, fractions, pi, anything like that. Real numbers can be broken down into rational numbers. So these are of the form P over Q is the technical definition, where you can write that as a fraction. So P and Q are whole numbers. So any number that can be written as a fraction. Irrational numbers are things like pi or e or square root 2 that you can't write as a fraction. Integers then are positive and negative whole numbers, so like -1, 2, 1, 0, etc. Natural numbers are just positive numbers, so 1, 2, 3, 4, etc. Okay, so what is an imaginary number? So imaginary numbers arise when you take the square root of a negative number, which isn't possible. So I equals the square root of -1, and all imaginary numbers can be written in some terms of I. So if we have square root of -25, that's the same as saying 5I. The I represents the -1 part. Because you could technically rewrite this as square root of -1 times square root of 25, and then this becomes the I, and that becomes the 5. Okay, so a note here, I squared is not imaginary, it's a real number. So this is actually -1. And then I cubed is going to be -I. I to the 4th is going to be 1. So it comes from, like, if you're taking the square root of -1 times the square root of -1, you just mash them together, the square roots kind of cancel out, and you get -1. Or, sorry, I'll write this out. So if you square root of -1 and you square it, your square and your square root cancel, and you get -1. And then you can keep doing that same process for the other ones. This is going to keep going on the same pattern. You go I, -1, -I, 1, etc., 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 etc. And so if we have I to the 50, we can actually figure out what that is. So first off the bat, that's an even exponent. So it has to be one of these because these are the even ones. So you want to decide, is it a multiple of 4 or is it a multiple of 2? Well, you can go through 50 can't be divided by 4, so it can't be this one. But 50 can be divided by 2, so it has to go with this one up here. So we'll get -1. Okay, adding and subtracting complex numbers. You're going to treat the I kind of like an x or a variable. So here you add the real parts to get 7, and then you add the imaginary parts to get -3i. So kind of treat it like an x. And then here, you got to be careful. You got to distribute in that negative. So you have 1 plus 7i minus 6 plus 2i. Now you can combine to get -5 plus 9i. Okay, now I have a slightly different one. This one's a little tricky. So I'm going to start by writing this first part as an I. And then the second part, this is the same as just one I instead of -I. If we go back to, sorry, this is the same as -I. If you go back to up here, I to the 3rd is -I. So I can replace that with -I. So it'll be minus here, minus a negative I, which is just a positive I, so it's going to be plus I. And I can combine the 8, or the 3 and the 5 to get 8. And then these chunks, we can't actually combine those two numbers together. But if I rewrite this as an intermediate step, I can factor the I out of both of these. So we'll get 8 plus I times square root of 7 plus 1. And then usually we move this I to the end when you write it. So you do square root of 7 plus 1 I. Okay, so then multiplying them out. Again, you're going to treat it kind of like an x. It just will be a little bit different at the very end. So 2 times 9 is 18. We have plus 10I plus 27I, and then plus 15I squared. So you can combine like terms. We'll get 37I. But then this chunk can become real. Because I squared equals -1, you get -15 right there. And now you can combine like terms again to get 3 plus 37I. So if you have an I squared, I cubed, I to the fourth, I anything like that, you can always convert it down to a 1, -1, or an I. So you should never have anything with I to a higher power because you can simplify it. So now if we multiply the next one, we have 49 minus 28I plus 28I minus 16I squared. So again, this is going to become a real number. These two cancel out. You get 49 plus 16, which equals 65. So a note here, in that last example, we got a real number. So a conjugate of an imaginary number is the same two a's and b's, but with the opposite sign. So a plus bi and a minus bi are called conjugates of each other. The property of conjugates is when you multiply them together, the imaginary parts cancel out and you're just left with a real number. So like up here, we had plus 4i minus 4i, we ended up with just 65 and nothing imaginary left. So using these conjugates to simplify fractions. So in general, we don't like having complex numbers in the denominator, just like having radicals. It's kind of like a grammar simplifying type thing. So to get rid of the 5 minus 2i on the bottom, you can multiply by the conjugate. So multiply by 5 plus 2i. And then multiply that out, we get 35 plus 14i on top. And then the bottom, because we have the difference of perfect squares, you'll get 25. The middles will cancel out and you'll get 4i squared. And then again, this becomes a real portion. So you get 35 plus 14i on the top, and then 25 plus 4, or 29. This to this chunk is always going to happen, so you don't have to write that intermediate step if you don't want to. The next one here, there's lots of options. So you could multiply by -3i to be the conjugate. That will work. You'll just end up having to simplify your fraction at the end. But since there's no real number in front of this, you can just multiply by I, because we just need an I squared to get an actual number. So I'm just going to multiply by I, but you could multiply by -3i and it would work. You just need to simplify the fraction at the end. So this will give you 5i over 3i squared, which then is 5i over -3. And that works. If you're done with the -3i, you would have gotten -15i over 9, and then you just simplify. And that's it. So your homework is on Schoology, and let me know if you have any questions.